morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are going to talk some quadratic equations as we listen to the great ABBA in the background. Let's get to it, shall we? We'll get back to Waterloo in just a second. Quadratic equations. What makes a quadratic a quadratic? It's a polynomial whose greatest degree is 2. Okay, it's a second degree equation. Meaning the greatest exponent is 2, and it must have that, or it's not a quadratic. Okay, solving quadratic equations. You can read through this if you'd like, but the biggie here is the Null Factor Law, which I would rather call the zero product principle. Okay, zero product principle, otherwise known as ZPP. And anytime I say ZPP, you reply with, yeah, you know me. ZPP, yeah, you know me. And if you don't, you fail for the quarter. That's it. And all the Null Factor Law says is if A times B equals 0, then either A is equal to 0 or B is equal to 0, or actually both. And that is the beauty of the Null Factor Law. Okay, and so if we factor it, all we need is one factor to be equal to 0. Let me show you what I mean. Well, here we go. To solve quadratic equations, we have the following methods. We can factor, we can complete the square, quadratic, or use technology. This is very important. The roots or solutions of a quadratic, this is the general form of a quadratic formula, or quadratic equation, by the way, are the values of x which satisfy the equation or make it true, which satisfy these equations. Okay, so zero product principle, ZPP, yeah, you know me. You better reply in that manner or there is going to be trouble. Okay, solve for x. So here we have 3x squared plus 5x equals 0. What do they have in common? Looks to me like they have an x in common, so I'm going to factor out an x. That leaves me with 3x plus 5 equals 0. And this is the beauty of the zero product principle. If you remember, that's A times B equals 0. So A equals 0 or B equals 0. Either one, if this is equal to 0 or this is equal to 0, I have a true statement. So I can say x is equal to 0 or 3x plus 5 equals 0. Solving, I have x equals 0. Here, 3x equals negative 5 or x equals negative 5/3. These are my two solutions. This cowboy right here and this cowboy right here. Yes? Note, you can't, if this was x times 3x plus 5 equals 10, you can't set x equal to 10 and 3x plus 5 equal to 10. It doesn't work. It's the zero product principle. Understand what you're doing here. You're having something times something equals 10. These would have to be factors of 10. Like this would have to be equal to 2 or equal to 5 or 1 and 10. Or 1.5 and whatever times 1.5 equals 10. So you can't use that principle here. That is a common error. For part B, we are going to subtract 5x and subtract 6, and we are going to factor. Factors of negative 6 that give me negative 5 are going to be x minus 6 and x plus 1. Again, we're going to use ZPP, yeah, you know me. Either one of these are 0. I set them both equal to 0. And I solve x equals 6, x equals negative 1. Booyah. Moving on. I'm moving kind of quick because really, this should be review for you. Okay. Here I'm going to set it equal to 0 by subtracting 4x from both sides. You should recognize this as 2x minus 1 times 2x minus 1, a perfect square trinomial, or more quickly, 2x minus 1 squared equals 0. So that means the only solution is when 2x minus 1 equals 0 or x equals 1/2. For this one, I subtract 11x and I subtract 10, okay? And I can factor those pretty simply. I don't care how you factor it. You should know how to factor at this stage. This is going to be, let's see, 6x squared, so I could have a 2x and a 3x. You could split the middle term here. This is going to turn out to be minus 5 plus 2, setting them both equal to 0. X equals 5/2. 3x plus 2 equals 0. X equals negative 2/3. Okay. If you need to know about splitting the middle term, you can Google that, or you can ask, I almost said form, middle term, or you can ask me, and I can show you real quick. Okay. Here we got a little bit of a different situation. What we don't like of this is, first of all, we need to set it equal to 0, and second of all, we have an x in the denominator, and it doesn't appear to be a quadratic just yet, but it really is. Let me show you what I'm talking about. So I'm going to add 7 to both sides. That equals 0. Then I'm going to multiply the whole darn thing by x, and that is to clear this denominator. Distributive property gives me 3x squared plus 2 plus 7x equals 0. I'll go ahead and split the middle term on this one. 3x squared plus 7x plus 2 equals 0, just to make you more comfortable in descending order of exponents. So to split the middle term, I take the coefficient of the squared term times the constant, and then I look for factors of the constant that give me positive 7 to make the middle term. So that would clearly be 6 times 1 equals 6, factors of 6, and 6 plus 1 equal, oops, that's not a 1, 6 plus 1 equals 7, which is the middle term. All right, so then I can rewrite the middle term as such: 6x plus 1x, 6 and 1, 6x and 1x. I'm not writing the 1 because we have on our big boy squirt right now. And then I look at this pair of terms and this pair of terms, and I factor them accordingly. What do these two terms have in common? They have an x and a 3, so I'm going to factor out a 3x, and I get x plus 2. And then I also get an x plus 2 here. Now, it might be that you have to factor something out of here in another type of equation or quadratic, but in this case we got kind of lucky. Now I have two distinct terms that have x plus 2 in common, so I factor that out of each of them, and what do I have left? I have a 3x, and the coefficient of this entire term is 1. And from here, you should be easily able to see that x equals negative 2 or x equals negative 1/3. Boo-yah! All right. What else have we got? We can complete the square. This is a skill that you should have already. It's very effective. If I have something like this, x plus 2 squared equals 7, I can take the square root of both sides. The right side must be plus or minus, because if I square a negative on this side, I will get a positive. So that turns into x plus 2 equals plus or minus root 7. So our solutions are negative 2 plus or minus root 7. And no, the 7 is not a perfect square. That is the exact answer. Let's leave it like this. Here, we would take the square root of both sides, and that becomes plus or minus square root of negative 5. We are in the real number system. We cannot handle the square root of negative 5. So for this one, there would be no solutions. Giddy up. All right. Next, what about this? Now here, is completing the square. We can't factor it. We could use the quadratic formula if we wanted to, but we do need the skill of completing the square. How do we do that? Well, I'm going to write x squared plus 4x, and I am going to leave a blank here because I'm going to add something here. So here's plus 1 equals 0, and I'm going to put something here to form a perfect trinomial square with x squared and 4x. And really what's happening is I am factoring backwards. I'm trying to find out what term here I can add or subtract to make a perfect trinomial square. So all I have to do is take half of the middle term, I'm sorry, not the middle term, half of the coefficient of the middle term, which is a 4, and then I square that, and that is equal to 4. It's just a coincidence that this coefficient and my result is 4 here. It's not always going to be the case. So what I'm going to do is add 4 here. So now all of a sudden I do not have the same equation, so I have to compensate by also subtracting 4. Or I could have added 4 to the right side of the equation. But I decided to do it this way. So why in the world did I do this? Well, I've just made a perfect trinomial square out of this trinomial right here. This becomes minus 3 equals 0. I add 3 to both sides. And now I can take the square root of both sides and get x plus 2 equals plus or minus root 3. It's not a perfect square. I'm going to leave it like that. And my solution set is as follows. Okay. Let's see. We can do the same thing here. It's a little bit more tricky with an exponent. I'm sorry, not an exponent. A coefficient of your squared term other than 1. So what I'm going to do is make it 1. And how do I make it 1? Well, I can multiply through everything by negative 1/3 or divide everything by negative 3. I think that's easier to show. And so then I have x squared, and 12 divided by negative 3 is negative 4. I'm going to leave a space here. 5 divided by negative 3 is negative 5/3. And 0 divided by negative 3 is 0. So half of negative 4 is negative 2. And I square negative 2 and I get 4. So again, I'm going to add 4 to both sides. And to compensate, I'm going to subtract 4 from this side. So now I factor this. X minus 2, the quantity squared, comes from here. That's the whole reason I did that. Negative 4 minus 5/3. Well, negative 4 is the same thing as negative 12/3. So that's going to be minus 17/3 is equal to 0. I'm going to move over here a bit. So x minus 2 squared is equal to 17/3, adding it to both sides. X minus 2 equals plus or minus the square root of 17/3. So x equals 2 plus or minus the square root of 17/3. Booyah! Done. Yes, you could have used the quadratic formula here, but completing the square is a valuable tool, as we will see later in this course. Quadratic formula, right here, it is on your formula sheet for you. Right here, you always know it if we're in the form of, or you always have it, if we are in the form of ax squared plus bx plus c equals 0. We can find the roots, the solutions for x, by using the quadratic formula. It is a beautiful proof. I will not take time on the video to do it, but there it is right there. And in fact, we prove it by completing the square and doing some very simple algebra. I encourage you to pause and see if you can follow through on this. It's a beautiful, beautiful proof. Using the quadratic formula, I'm just going to do one of these. I'll do this one. Ax squared plus bx plus c equals 0. So A is equal to 2, B is equal to 3, and C is equal to negative 6. So X equals negative B, so that's going to be negative 3. Now if this were negative 3, then this part right here would be positive 3, plus or minus the square root of B squared, which is 9, minus 4 times 2 times negative 6. A is 2, B is negative 6, all over 2 times A. So I got to clean up in here, negative 3 plus or minus the square root of 9. 4 times 2 times 6 is 48. How do I know it's positive? Because I have a negative times a negative here, which is a positive. All over 4. This equals negative 3 plus or minus the square root. 48 plus 9 is 57 over 2, which is a perfectly acceptable answer. I don't believe that, no, 57 can't be simplified, so we are good there. You can always use a calculator to solve a quadratic, and let me just show you this real quick. I have my GDC up, okay, and I have it open to Scratchpad on purpose. I want you to stop using Scratchpad. I want you always to use a document, and it's just so important, and you'll see later on in the course and how I explain it in class. So I'm going home, new document, and I'm going to show you how to do it using a calculator, and then I'm going to show you how to do it graphing. Menu, got some algebra going here, polynomial tools, and I want to find the real roots. We're in the real number system, we're not in the complex number system, so we're always going to choose real roots of a polynomial. Okay, polyroots. Okay, and we're going to solve this one, x squared minus 5x equals 6. So I'm going to do x squared, I'm going to enter that, minus 5x minus 6, and then I'm going to hit a comma, and it has to be in terms of x, and I hit enter, and I get the roots. Is that the greatest thing you've ever seen in your life? It's negative 1, 6. How about that? Okay. Now I'm going to add a graph to show those roots. Control, and I go to document, and I want to add a page to my document, and I'm going to add a graph. I'm going to graph that, and it was, I have a short-term memory issue, x squared minus 5x plus 6. So x squared minus 5x plus 6. Boom, chugga-lugga-lugga. Did I do that right? I feel like it was minus 6. Yeah, minus 6. Okay, so I messed that up. So I'm going to hit tab to fix it. I arrow up and delete, make that a minus. Life is good. And you can pretty much see where the roots are. Again, the roots are where the function is equal to 0. And the value of a function is always its y value, its y coordinate. If you're not convinced, we go to menu, analyze graph, and we find the zeros. Lower bound, in other words, I go to the left of the x-intercept, drag to the right, and I get my solution negative 1. I have another one over there, analyze graph, find the 0, left of the intersection, right of the intersection, boom, chugga-lugga-lugga, and there we have it. I'm going to copy this real nice for you and put it so you have it to see. And that's the other, whoops, that was awkward. So you have it that way, or we go back here and you have it this way. Now, I'm going to show you something else. This is a big reason why you should always work in documents. We have this function as the first function, f1 of x. Look what you can do. Okay, if it's already entered on a graph, if you already have it as a graph, you can go menu, algebra, polynomial tools, real roots of a polynomial. So same thing, polyroots. But I can type in f1 of x, put that in parentheses, comma x, enter, look, I get the roots. Because the calculator knows, since we're in a document, we're referring to this function. So a great tool that we can have. Very, very powerful, especially later in the course. All right, hope you enjoyed that. Let's check back in with ABBA, see how they're doing. Waterloo. Not if I wanted to. I hope you enjoyed it. We'll see you next time. And I am out.